After the player shoots, we should give the player some positive feedback, such as displaying the shooting score and hit rate. Let's implement score statistics and display. Here we intend to display the score and hit rate that players are most concerned about. First, we need to design two display areas in the game UI. Open the progress bar UI. In the UI editor interface, drag text to the hierarchy window and name it Goal. In the inspector window on the right, set its content to Goal. Set its position to top center. Adjust its left side to align with the left side of the health bar. Right-click Goal, select Create, General, Text, and create a child node. Name it Result Text. Set its content value to 0. Adjust its position. Drag text to the hierarchy window and name it Heat Rate. Set its content value to Heat Rate in the inspector window on the right. Adjust its position. Right-click Heat Rate, select Create, General, Text, and create a child node. Name it Result Text. Set its content value to 0. Adjust its position. Change the text box color to an appropriate value. Press Ctrl+S to save. Next, modify the code. First, you need to get the components used to display the score and hit rate in the progress script. Declare two variables GoalText and HeatRateText. Then, get its node in the onStart method. Then, declare two variables in the basketball controller script to record the total score and hit rate respectively. The total score here is accumulated from a single score, so we also need to declare a variable to record a single score. This also makes it easier for us to determine a single score based on the shooting distance later. The hit rate is equal to the number of hits divided by the total number of shots, and then converted into a percentage. Therefore, two variables need to be declared to record the number of shots and hits. Now, we need to accumulate the number of shots every time we shoot. At each goal, accumulate the number of goals and calculate the hit rate. The accumulated score is also handled here. Here, we grade the score of each shot based on the distance. Because the initial position of the basketball has been recorded in the basketball control script. Therefore, we can calculate the shooting distance at the moment of hitting. In this way, subsequent shots of the basketball into any basket will not be affected. Calculate the distance between the shooting point and the collision body in the net, and score 2 points by default. To see the relationship between the score of each shot and the distance, we can switch to the top-down perspective. If the shooting point is within the 3-point line, a goal is scored 2 points. If the shooting point is outside the 3-point line and does not exceed the half-court line, a goal is scored 3 points. If the shooting point exceeds the half-court line, a goal is scored 5 points. There is a little trick to measure the distance between the 3-point line and the basket. Let's create a new sphere. Switch to the top-down perspective of the 2D view. Then adjust the position of the sphere to the basket and record its Z value. It is about -10. Then drag the sphere to the 3-point line and record its Z value. It is about -4. In this way, we can calculate that the distance between the 3-point line and the basket is 6. Then pull the sphere to the midfield line and record its Z value. In fact, you don't need to pull it here to know that the Z value of the long-distance line is 0. In this way, we calculate that the distance between the midpoint of the long-distance line and the basket is 10. It should be noted that it is not that the distance between the shooting point and the basket is greater than 10, which exceeds the midfield line. For example, this shooting point is more than 10 away from the basket, but it has not crossed the half-court line at this time, and the goal can only get 3 points. Therefore, the condition that the shooting point that scores 5 points should meet is that the distance between the shooting point and the basket in the Z direction is greater than 10. After the analysis is clear, we will complete the method of scoring and distance. First, calculate the case of 5 points, that is, the distance in the Z direction is greater than 10. Then calculate the case of 3 points, that is, the projection distance in the XZ plane is greater than 6. We have completed the scoring statistics. Finally, we need to display the scoring data onto interface. To keep it simple, just update the scoring data time the update method of progress script. Because, in basketball controller class, we set the total scoring data to modify by private, and within Twan external class to modify the properties, so need to private method synthesis class for external access of the values of the properties. So that can be displayed into interface. Here we set the return value to string, because the string needs to be passed in when displaying. To display the hit rate as a percentage, we multiply the hit rate by 1000, round it off, and then divide it by 10 to get the value displayed as a percentage and retain one decimal place. For example, if the calculated hit rate result is 0.9876, multiply it by 1000 to get 987.6, round it off to 988, divide it by 10 to get 98.8, and then add the percentage sign to get 98.8%. Finally, add the display logic of the score and hit rate in the onUpdate method in the progress class. Run, shoot multiple times, and test whether the score and hit rate are displayed correctly. It is found that the hit rate will not be updated when the shot is missed. Check the hit rate calculation logic, and we found the problem. Our original logic is to calculate the hit rate only when the goal is scored. In fact, regardless of whether the goal is scored or not, the number of shots has increased, and the hit rate should be recalculated. Just make a slight modification to the code. In the case of no goal, the basketball becomes idle as soon as it lands, and the hit rate is updated immediately. In addition, adjust the width of the UI display area appropriately to ensure that the display does not wrap. Ctrl+S saves the changes to the UI. At the same time, remember to delete the sphere used for distance measurement in the scene. Ctrl+S saves the scene. Run and test. So far, we have completed a fixed-point free-throw gameplay. However, as a game player, you cannot observe the process of basketball scoring at close range at this time. Students who often watch basketball games may find that indoor stadiums for large-scale events usually hang two screens on the left and right of the basketball stand to display the scene of the goal in real time. Let us think about how to achieve this.